Okay, so I use something called JSBin. And I could save my work on JSBin if I want to, but again, it doesn't matter. You could use any tool. I'm logged in. You don't even have to be logged in to use this stuff. I'm not concerned about the HTML. I'm going to use the JavaScript here, and I'm going to use the console. So I'm going to start out by saying console.log hello. And one of the problems here is that JSBin actually keeps the console alive. Sometimes that can get a little bit confusing. So I always go here, and the first thing I do is I do console.clear. Okay. So what I want to do here is I want to create a linked list. So I'm going to specify const ll equals new linked list. This doesn't exist, and I'm going to end up creating it. And I'm going to say, here's my function linked list. Later on, we could talk about turning this into ES6 classes. Right now, we'll just deal with plain old functions at the moment. So here's our linked list. Now I can end up creating a linked list. So what are some of the things I want to be able to do with the linked list? Okay, I'm going to have a very simple linked list. I'm going to have foo followed by bar followed by baz. Okay, so I'm going to be optimistic and think that what I can do is I could end up adding to head, and I'm going to say bar. Okay, this doesn't exist yet, so let's actually go and create that, and then we'll test out whether or not it works. So first thing I'm going to do, and I'm going to do a prototype. Okay, I'm going to say prototype of my linked list add to head. This is going to be a function. By the way, if you tried to do this with the fat arrows of ES6, it won't work for you. If anyone tried that, the reason why that won't work is that fat arrows don't give you the correct binding. They don't give you any binding, really. They bind to whatever is there at the time, so it's not going to work on a prototype. I actually found that out myself recently. So what I'm going to do here is that this is going to end up taking a value here. I'm going to keep it simple. I'm not even going to create a node class. Keep it a little bit simple. Well, what do I know that I need to do here? If I'm adding to the head, I'm going to have a node, and that node is going to have a value. By the way, this is shorthand. If I just do this, it's the same as doing this. It's the exact same thing. If you basically have a value and you create an object with it, and you say, hey, look, I want this value to be in the object, it'll name that key the same as that value. So this is the equivalent of doing this. That's my node that I'm going to end up adding. And I think sometimes it doesn't recognize the ES6. That's why I'm getting a little line here. But let's just sort of think about our edge case for the moment. Our edge case at the moment is that you have no head and you have no tail. Okay? You can't, if you don't have a head, you better not have a tail. If you don't have a tail, you better not have a head. So I'm going to ask the question, hey, look, if not this dot head and not this dot tail, then I've got something very simple that I can do here. I could just say this dot head equals this dot tail, which is going to be equal to this node. Okay? I don't see any errors popping up here, but let's actually write a little function that'll help us traverse through the linked list. So what is that going to look like? So let's actually go over here, and I'm going to have a function. I'll call it print. It's going to end up taking a value, and I'll go over here, and I'll say console.log. Let's just call it value. Fine. And I'm going to go over here, and I'm going to be optimistic, and I'm going to say, hey, look, I can traverse through my linked list with the print function. Okay? Again, I get this error because traverse doesn't work. So how would we go about traversing through a linked list? Well, again, let's use our prototype. This is going to end up getting passed in a function. And what does traversing mean? Now, I could go in either direction. Okay? I could traverse from the head to the tail, from the tail to the head. What I'm going to do here is I'm going to use a let. So the difference between lets and const is that if I'm going to end up assigning something to the variable, I use a let. If I'm not going to end up assigning something else to the variable, I use a const. Okay? So I'm going to go over here and I'm going to specify current equals this dot head. And I'm just going to do a while loop and say while current. Now, one thing you better do with the while loop is you better have some way of getting out of the while loop. So what I'm going to do here is every time I go through here, I'll say current equals current dot next. Right? I want to end up going forward through the linked list, starting with the head. And every time I do that, I'm going to call current with the value. So I end up getting bar, which is the first element in my linked list. So let's just test one other thing out here. I'll change the order here in a second. But what happens if I end up adding to head foo? Okay? I still only have bar there because I've only taken care of my edge case, which is this. Now, if I make it down here, okay, if I make it down here, what does that mean? Well, that means I actually have a head and I have a tail. I want to add something to the head. So again, I've got my node that I created. So the logic there is to say, hey, look, whatever the head was before, okay, its previous value is going to be this node, okay? Again, the whole idea is I'm working with these references. So whatever the head was before, its previous value is going to be the node. What I'm doing is I'm just hooking up the structure, but I've got to be careful of the order that I end up doing it. The other thing that I'm going to also say is, hey, look, node that you just added, okay? Node that you just added, you're at the head, so your next value is going to be a reference to whatever the head is. And last but not least, the last thing that I have to do is to say, hey, look, there's a new head here in town, and the new head is going to be node, right? So I ended up adding to the head bar and foo, and this is what the order is. Okay? This is basically the logic to add to the head of a linked list. Again, the whole idea here is that the order is critical. I can't wipe out this reference. Okay? So I've got a reference to the head. Okay? It didn't have a previous before. If you're the head, you better make sure you're going to be in trouble if your head is pointing to a node and there's a previous value. It doesn't make any sense. Okay? So the previous value for the current head has to be the node that you're adding. The node that you're adding, its next value has to point to whatever the current head is. And now there's going to be a new head, which is going to be the node that we're adding. So let's just test this out one more time. Let's actually do it with our, we'll go over here and we'll say LL add to tail, and we'll say Baz, right? Right now, this doesn't exist, but I'm going to cheat a little bit. A little copy and paste. Elliot likes to say copy pasta. Just figured out what that meant not that long ago. Okay? So we want to go and add to tail. And so when we want to go and add to the tail, what we're going to end up doing is we're adding to the tail. Again, our edge case is exactly the same. No head, no tail. Fine. That's the node that you're adding.
Can I say something right
Sure.
now? You're going to hate this, but it's important to say. If you find yourself copy-pasting code and just changing variable names, you're probably breaking a core principle. Does anyone know the name of that principle? Try. We're probably doing the same logic 2 different times. There's probably a way to clean this up. That being said, let's not do it here.
No, that's true. There's 100%. And by the way, that's actually one of the reasons why I love having testing. Because with testing, you could say, hey, look, I don't care. I'll copy and paste it now. And then I can just make sure, like, let me pull it out and dry it out and make sure it doesn't break anything. But that's 100% correct.
That's all.
So when we go to add to the tail here, we're just going to sort of do the reverse. So you got to think this through a little bit. So I'm added to the tail. What does that mean? This means that I'm going to take the tail's value, and its previous is going to be the node that I'm adding. Is that right?
Inverse.
Shoot. this dot, that's right, this dot tail dot next equals the node that I'm adding. And then the node that I'm adding, its previous value is going to be this dot tail. And now I add it to the tail. So there's a new tail, which is going to be this node. And again, this ends up printing out correctly. Okay? Now, let's just do one other thing just so we could see it. Let's just say I have this ability to, give myself a little space here. I have the ability to traverse. Let's just see what happens if we say traverse backwards. And again, this we could dry out too. But if we wanted to traverse backwards, the only difference here would be that we would start at the tail, and the current would be the current dot previous. And then we'd be transferring back, we'd be going backwards. And as you're doing this, as you're testing this out, you can always do something like this to kind of break things up a little bit, okay? So we're going forwards and we're going backwards here. And just to sort of beat a dead horse a little bit, we could also just modify this. If we want to keep this order, we could say, hey, look, we're adding to the head bar here. Oh, that's fine. That'll do it, right? So we added bar to the head, then we added foo, we added baz to the tail. That's testing out all the functionality. So the next part is we want to be able to remove from the head and we want to remove from the tail. This is a little bit trickier. And again, we're going to have to take advantage of what the edge case is. So what is that going to end up looking like? I know this works. So let's go over here and let's say console.log ll remove from head. Doesn't exist. What would we expect to get back if we end up removing from the head? We should get the value foo back, right? So we're going to go over here. And we'll go over here and we're going to say remove from head. I'm not going to think about the edge case at the moment here, but let's actually go over here. We're going to remove a value. We're not passing anything in here. So what we're going to do here is we're going to say the value that you're going to return, we call it value if we want to, right? We're removing from the head. Is this going to be this head dot value? That's what's got to end up going back, right? And I can return it here. And I'll see that if I do that, I'll see the value foo here. But notice nothing ended up getting removed. So how do I go about removing that? Well, one thing we can probably do here is that we've got that edge case that says, what if we have nothing left? What if our head is equal to our tail, right? If our head is equal to our tail, that means we only have one node there. So let's take care of that edge case. We'll say, hey, look, if this dot head equals this dot tail. And basically that triple equal sign says, hey, look, you're pointing to the exact same object. You're the same object in memory. There's only one of you. Still a linked list. It's empty. It's not empty. It's got one element, soon to have no elements. So what do we know we're going to do after this? At this point, we say this dot head equals this dot tail equals null. Basically wiped out the list. Otherwise, what do we want to do? We're going to go in here, and now we've actually removed something from the head. So what do we have to do here? We'll specify, hey, look, the head equals whatever the head was before its next value, right? That's what the new head is going to be. And if it's going to be the head, what do we know about the head? The head's previous equals null. That's what ends up making it the head. So now we could see we've ended up getting foo back, and now we have bar and baz. Let's just put a little break here so we can see that. And just to sort of do this one more time, if we decided to do this, we remove from head again, right? Now our list just has Baz in it. Let's also just do the opposite, and we're going to end up removing from the tail.
If you keep removing until the linked list empty, then it will cause an error.
I don't know if it will. Let's see. Let's see. There's going to be nothing to remove. It shouldn't happen because if I keep on removing, that's right, that's right. So if we remove from the head, that's right. So one thing we could probably put up here, just as a blocker here, is to say, hey, look, and do it however you want to do it. If not, this dot head, and I shouldn't have to do both of these because if I do, something is probably broken, and not this dot tail. Throw in errors. Do whatever you want to here. All right. Again, I'm not really, I have a little bit of control over it. I'm not, again, the specs are a little bit simpler here because there are no specs. So let's go over here, and let's also just do one other thing here. Let's go over here, and let's remove from tail, which doesn't exist. Okay? So let's go over here. Again, I'm going to cheat a little bit. And again, we could always dry these out. That's, again, the nice part about having testing. Once you have some code that's working, we could remove from the tail. So now the value that we're going to return is going to be the tail value. Okay? This same thing exists, right? If the head is the same as the tail, it's the last thing there. We're done. The head is equal to null, and the tail is going to be equal to null. Otherwise, what do we want to do here? The new tail is going to be whatever the current tail's previous. And then if you're a tail, what's the definition of a tail? By definition, this tail dot next is equal to null. Right? So we've basically taken everything out here. So now, again, my whole point with this is to say, if you're going to try to implement something, whatever it is, you don't necessarily have to do it through a workshop. Just open up JSBin, start writing some code a little bit at a time. Right? This stage of the game, if this stuff is pretty new to you, okay, what I always tell people is don't write too many lines at the same time. Okay? A couple of lines of code, see if it works, because the more lines you write, you're not going to really know exactly where the error is. You're going to do some debugging. Okay. Let me stop this for a second. Got this working code. And again, just to see this one more time, I'm going to let's see, I'll make a directory, linked list, exercise, and I'm going to CD into it. You can do it in 2 steps. Either way, it doesn't really matter. Okay. I'm going to do an npm init, yes, with the default settings. I'm also going to do a git init. And I'm going to do an npm install, and I'm going to do mocha and chai. And I'm going to save it. And again, if I end up saying git.status, it'll tell me, hey, look, I'm going to include your node modules package, which I don't want to. So I'm going to touch a git ignore. And I'm just going to use this echo command and echo node modules into the git ignore. All it did was put the line, this is just going to put the line node modules into that git ignore file. You could do this in your editor. If I look at git.status now, I'll see my node modules aren't there, and I'll just say git.add git.commit first commit. Okay? So now let me open up, by the way, right now there's automatically you get a test command. If I say npm test, it'll actually run this echo, no test specified. Let me open up my editor. And what we're going to do here is in my package.json, I'm going to replace this, and I'm going to say test, and I'll say node modules, and I'm going to say mocha, bin, mocha, and I'm going to specify I'm just going to give a pattern of the test that I want to run, star.spec.js, and I'm going to do it with a watch flag. Okay, so I'm running mocha, and let me go over here and actually add a file, and this is going to be linklist.spec.js, and here's my linklist.spec, and if I went over here and I said npm test, it'll say, well, I did find a file, but there's nothing in there, and let's start writing this out. So I'm going to say const expect. I get this from chai, and chai has the expect function. I'm going to describe a linked list, and I'll go over here and I'll say it can add to head and tail. I know I'm using the fat arrows, which you guys have seen the fat arrows before? Yeah? All right. A little bit less typing. Sorry. So I'm going to write an expectation. Okay? I'm going to say expectation values to equal. Okay? I'm not doing equal, the full word equal. This equal says, hey, look, if you give me an array, I'm going to see if the values are the same in the array. And I'm going to be optimistic and go over here and say, if this works correctly, this is going to be foo, bar, and baz. Of course, what's going to happen here, by the way, sometimes Mocha does not pick up the changes, and I'm not sure why. But I could see it'll tell me values are not defined. And what I'm going to do is I'm going to take all this code that I have here under my JS bin, all this. Try that one more time. Command C. I'm going to take it and put it over here. I'll eventually separate it out. Let's take some of this stuff out. So our functionality here, what are we testing out, is I'm going to specify LL equals new linked list, LL add to head, foo, LL.add to tail, bar, LL.add to tail again, baz. And I'm going to use my traverse function. The way that I'm going to do this, I'm going to say values equals an array. And if I traverse, for each of these, I'm going to get a value. And I'm going to say values.push value. So if our traverse function is running OK, let's see if this ends up passing. Right, and this tells me I can add to the head and the tail. Again, just sort of using this traverse function to figure out that this is working correctly. Let's do one other thing here.
We haven't tested traverse.
Right, that's right, that's right. I haven't tested traverse. I'm sort of testing it indirectly, right? So let's go over here. Let's just do one more thing. I can remove from head and tail. We know it can already. So here we'll add to the head and tail, and we'll say expect ll.remove from tail. This we expect that this value to equal the actual value baz, and the traverse function should actually probably fail because we removed something from the tail. We'll get that to pass, but let's also just run. And I'm putting a lot of these tests together just to make this a little bit faster.
Normally you break these tests.
Break these in smaller chunks. So remove from head should be foo, right? And this breaks, what should I be left with here? I should have bar.
Ideally, the way you should write unit tests is you should test each function you want to use before you do something with multiple functions.
Right.
So you would test like at the head, and then you would test at the tail, and then you might have a test like can add to head and tail.
Right. This is definitely more of a composite test. And then this will end up passing. Now let's do the last part here, which is searching. I'll cheat a little bit again. And again, all this stuff can end up getting refactored, but let's just cheat real fast.
Before each would save you a lot.
I know. So let's go over here, and let's say it can search. Let's say it can search a value. So let's add these. We won't remove. We're not going to traverse. We won't look at the values, but we'll write an expectation. Hey, look, LL, I should be able to search you with bar. This should equal bar, right? Search basically returns the value that you're looking for. And if we look at this, we'll see that search doesn't exist. Let's go and implement it. So this is going to be search, and I'm going to name this in advance because I know I'm going to do search a little bit differently. I'm going to call this match.
The capitalized?
No, it's not. Thank you. So we'll go over here, and when we go to search, we're simply going to go over here, and we'll say const current equals this dot head while current equals current dot next, and we'll just go and we'll ask the question, hey look, if match equals current dot value, then what we're going to end up doing is we'll return current dot value, right? Basically this takes us out of the while loop. It ends up returning the value. Assignment to constant, that's true. Can use a const there because I'm basically clobbering it. And this will end up passing, which is sort of the easy one.
Can you not use double equals?
Yes, thank you. Right, this is going to be the exact value. Thank you. Okay, and let's do one other thing. Let's say it can search for a value with a function. So let's write a match function. So here's a function we're going to call match. It's going to get passed a value. And let's just say we want to find, we're going to return if the value index of BA is equal to 0. We want to find out if, in fact, we actually have something in our linked list that starts with BA. We actually have two values that are in there. And so now when we search, we're going to search with our match function here. This is not going to end up passing for different reason here. Match is going to be a const. And let's see what I'm missing here. So it's got to be something on this line, right? Maybe? Yes. Pass in that function. And I end up getting undefined. So I'm just going to ask the question up here. And again, we could always refactor it to make it nicer, but I'm just going to, while I go in here, I'm going to say, hey, look, if your match, if type of match is equal to function. I'm going to put an else here. And again, if we get this working, we could always end up drawing it out a little bit. So what's my logic here? So if the type of match is a function, if match by passing in current.value is true, then we're going to return current.value. And that will end up passing as well. Okay? So again, the goal here was, again, to see a little bit of test-driven development. Here, there's a lot of functionality. You can do this as an exercise on your own. Once this is working, there's a lot of common code here that you could end up pulling it out and putting it in other functions and drawing this out a lot. But as long as we're here, let's actually just save it up to GitHub, git.stat. Oh, one other thing here. Let's pull this out. This is not great to have our code in here. So let's take our linked list functionality out here. And again, you don't write this from scratch. You do this stuff a little bit at a time. Let's take this, linked list.js, paste this in here. And I'm just going to go over here, and in order to use this, I'm going to say module.exports linked list. The reason why you don't have to do this with testum is testum puts everything in a global namespace. So this is Node, some stuff that we'll be getting to later on. But we could end up doing this, and then all we need to do here is say const linked list equals require / linked list. And we're still passing, which is a good sign. And now at this point, I could look at my git.status, git.add, create linked list with test. That's always nice that you have some test there. And what I'm going to do is now I've written this locally. Let me push this up to a GitHub repo that I could give you access to. So I'm going to go over here. And let's go and got it. Okay. So I'm going to go over here. Similar to what I did before, I'm going to call this profs linked list exercise. Make it public so you can access it. I'm going to create the repo. And I already have a repo that exists, so it's just a question of using this code to basically now make this Git repo my source of truth. So if someone was to walk over and pour some water on my keyboard or something like that, I would have it up here. And now I've got this on GitHub. Okay? So let me stop this so it doesn't go on